Hi everyone, I'm Sarika Sinha. I work with IBM and I've spent over a decade with Eclipse projects, and currently I'm co-lead of Eclipse platform and JDT projects. So let us learn how to write structured concurrent program with Project Loom. We will try to understand the motivation and goal behind the Project Loom, the difference between virtual thread and the normal thread, why, when, and how to use the virtual threads, and how to control the running task using deadlines. And finally, we will learn how to debug the virtual threads. The OS level threads are very limited and they depend on the power of the machines and the cores. And in the current demanding world where we know that all the processes are competing for the computational resources, the there are interactive methods and non-deterministic functions, and we have concurrent databases, servers, which serves around millions of requests per second. In these situations, Project Loom started with exploration of how to provide Java with the native support of the VM and providing some APIs for the user to be able to write simple and lightweight, high throughput constructs. And this can be achieved with continuations, virtual threads, and tail call elimination. A recursive function is tail recursive when the last execution of the function is a recursive call. And in these scenarios, the compiler can optimize the flow and it can convert it to a go-to to avoid the stack overflows. But this is still a future work as part of the Project Loom. Virtual thread is not an atomic construct. It is a combination of continuation and the scheduler. And there was enough evidences to see that continuation has much more use cases than virtual threads. So it was decided to open up this as a user interface. A continuation is a stack of function calls which can be stopped and resumed later on the will. And there is no external scheduler, so we must write our own. So let us see in the example how we can use continuation. Continuation has a lifetime scope which is bounded by continuation scope. So here we can see we are creating a continuation scope, and this continuation will yield or run within this scope. So if I run this program, we'll see that the first task which will happen is the start run. And then the continuation will start and it will print the start C1. But after that, the continuation has stopped its task. And now it moves to end run. And then again, as the continuation is still not completed, it goes back to start C1 and again it yields. So we will see, so we see that there is a continuous yield and run, and it is totally controlled by the user. Also, continuation provides a method to get the current continuation inside a scope. So this is a very similar method, but only difference is here we are trying to print the current continuation. So when we see that the continuation is active and it is not yet completed, the current continuation is printed, but after the execution is complete in the end, the current continuation becomes null. So there are several examples, like we said, of continuation. Like one of the famous example is of the generator, where iterator can be implemented using continuation. And we can see here, for each has next method, the continuation is run and the next element is generated and the continuation yields. So the element generated can be returned by the next. So this goes on and there is no blocking of the thread over here. Similarly, we can see the usage in a server where read and write IO is happening. In this situation also, for waiting of the key read or write, there is no need to block the whole thread, but the continuation will just yield. So now let us understand how the virtual thread is made up of these continuations and scheduler. Virtual thread is actually just a thread, but it is scheduled by the Java virtual machine rather than the operating system. So this was decided as we should not be dependent on the OS and kernel level scheduling. Here JVM is already equipped with the scheduler which can schedule the virtual threads. And these are normal priority daemon threads. The priority cannot be changed and the daemon property also cannot be set again. There is no permission with the security manager, and inactive threads in a thread group are these virtual threads. And there's no support for thread suspend, resume, or stop because these are not the normal thread APIs. So let us understand how we can write a structured concurrent code using the virtual threads. In this situation, the main task is actually split into several concurrent tasks which will be implemented by these virtual threads. And all these virtual threads are scoped and which has a lifetime of the continuous scope. So there are many advantages of scoping it within a continuous scope, and that is we know that these virtual threads are born here, and before the completion of the scope, all these virtual threads will die inside, and these can be nested also. So the exceptional handling, and also if you want to do some final action, it can be done at the end of the scope of the continuation. So the scope helps us to uh, monitor and understand and also trace out the calls of the virtual threads. And thread start virtual thread or the executor APIs can be used to create the virtual threads. ExecutorService provides the submit and invoke methods, and these don't block the threads, but they just return future objects which can be lazily populated, and it can contain a result or exception for future analysis. But we have to understand that this does not impact any older fork join pool APIs. So let us also understand that these virtual threads are how can we code them. So this is example of a simple virtual thread, starting of the virtual thread, and we are just waiting for the completion of it. Also, the virtual thread can be used along with the synchronous key. So the synchronous key is going to wait till this virtual thread has added the message done in the queue. And as this thread is sleeping, we will see that after a wait of 2 seconds, this done is going to be printed. And here is an example how to use Executor API to create a new virtual thread executor. And we can submit a runnable task, which will return a future object. We can wait for this. Also, we can call the submit method where it is going to return a list, and this will return a stream of future objects which can again be filtered, and we can use all kind of stream APIs, and we can filter if the completion was normal uh, or we can filter on any other condition. We also have invoke all method which can wait till all the execution is completed. Also, we can pass the value true, which can make sure that if any of the execution has thrown exception, it can cancel the other remaining executions. It can also invoke any, that will mean that if we run this, whichever is executed first, it will just stop, and it will not wait to execute the pending tasks. So let us try to understand how we can use deadline to wrap the executor services. This way we can say that only we are going to wait till this deadline for any of the thread completion. And if the threads are not completed by this time, this whole executor service is going to stop and all the threads will be terminated. And the deadlines apply to nested usages. The deadlines can expire before the executor and it can terminate the executor. So we can see and test an example. So here we have created a deadline with 2 seconds, and we have passed the deadline in the virtual thread executor. So 2 seconds should be enough, and we can see that the threads were submitted normally. Now let us try to decrease the deadline. So now the deadline is just 1 millisecond, which should be quite small to execute this. And now we see that it has actually resulted to a rejected execution exception because the executor could not finish and it was rejected due to the deadline. And finally, let us understand we don't have much support on debugging till now because virtual threads are just objects in the heap and there can be millions of them. We can do create thread dumps, which will generate virtual thread details as well. But this is the just the stopgap methods for now. And the virtual threads are not the active members of a thread group. We can always test by is virtual method to know if a thread is virtual. And for the event requests, we can call thread set and thread end methods with a filter of platform threads only, because by default this will notify the threads and the virtual threads as well. But temporarily there has been a few additions to work, like there is because all the builds does not have the project Loom included, so we can test by using support virtual thread that the VM is supporting virtual threads or not. And there are some temporary JWP options, like for enumerate threads. As we know, virtual threads are not part of the enumerate threads or the thread.children methods. In these cases, this JWP option can be used with Y flag to say that no, we want virtual threads also to be enumerated. And also for the thread start and death events, by default it is sent to all the virtual threads and the threads, but N flag can be used to notify only the platform level threads. But if platform level filter has been used, that definitely takes the precedence. But these are all just for temporary and this will go after some time. The problem with debugging of virtual thread is that each of the virtual thread is mounted on a carrier thread. And if we have a breakpoint at a position where all the virtual threads are going to hit, in those scenarios, what happens? The There will be mounting and unmounting happening continuously. And either the threads will be yielded on the suspended point or the other threads will be waiting to get the carrier threads to run. So this will not help us to debug. So we have to apply the debugging points smartly, and where not all the virtual threads but the main carrier threads are suspending. And also while stepping in, it should resume all the threads rather than a single thread. Also the threads are scoped with the with has a life of the scope, which is a continuation scope, which we have seen. And for the same thing, we know that uh, we can always debug it within the span of that and write a function which we want to handle if there is a scope if it has to be handled after the scope completion. So let us see how to debug virtual thread program. So here is an example of the enumerate, and we can see that I've created a thread, normal thread, and inside that there is also a virtual thread, and there are two thread groups, and we are enumerating one thread group, and we are testing the is virtual for the thread. And if we run this, we can see that the is virtual is false for each of them, and the we get only two threads, which are the main threads created, and the virtual threads are not enumerated by this method. Also, let us see how we can debug, and what are the problems in debugging virtual thread application. So here my machine has 16 cores. So if I try it with 16 virtual threads, and if I have put a bad breakpoint, and we can see that all the virtual threads have stopped over here. And if we try to step in over here, this will not be an issue, because each virtual thread can get a carrier thread. We have enough carrier threads available. In normal situations, the carrier threads are less, and the context switching happens, which is very costly. And for the virtual threads, the context switching is estimated to be in nanoseconds, and the metadata of these threads to be in some bytes, and there will be no OS level stack data written, and the stack will be just and it will be growing and shrinking depending on the number of virtual threads available. But now if we try to increase the virtual thread more than the carrier threads which this machine can support, so let us try to debug with such an example. So now in this case, when we try to step in at a position where it is going to, the sleep is going to yield this thread. So when we are going to do, see this this appears to as if the this did not the going to the next step did not work. But what has happened behind it is this virtual thread was unmounted by the carrier thread, and that carrier thread took up and mounted some another virtual thread which was waiting for the task, and this will come back once this virtual thread gets a carrier thread. So we have to be smart to apply the breakpoints and debug these kind of programs. Let us also see how the performance can be measured. So I just have a simple task to generate some numbers, and when I use the normal thread, and I will be just trying to see how. So we can see 1033 threads with 120 odd MB data was used. Now let us try to use it with virtual thread. So we can see the number of threads have decreased, and the memory consumption has drastically decreased. We can also use it with the executor APIs, and this is expected to be in the same range or little lesser than. So we can see it is in the same range here. So this was all I had, and we can see some references. This is the wiki page by the project Loom, and we can get all the latest updates about the support here. And currently, the early access build is built on the Java 18, which I am also using currently. and we can download the build from here. So do remember to evaluate the session and give the feedback. Do join the conversation on Twitter with different Twitter handles and EclipseCon hashtag. Thank you. Hi, everyone. And so I wanted to add on this that these APIs are still evolving. The project Loom, the constructs and the APIs are still not final. The continuation also may have some changes. It might get converted into an internal class. So the way I have demoed might need some code changes. And there might be some custom scheduler APIs which might come in the first preview version or in the later ones. Things are not yet clear, and the main thing is the concept of virtual thread will remain the same, that these threads will be lightweight and fast, and we can use it for unblocking the major threads. And the debugging APIs are the one which IDEs will need, so that we can use and control the flow and inspect the variables. So these are all the things we are still expecting it to come with the Java 18 preview, but it is still not announced, and it may come. The current version of the early access, we for if we want to try this out, we have to download it as I showed in the reference page. It can be downloaded from the early access build page from the Java project Loom, and it is available currently only with the Java 18 version, not with the previous versions. So the first question was similar here, that what do we need to try it out? Is an open JDK 17 all that we need? Any special flags necessary? So as I said, we need the Java 18 JDK libraries with the project Loom. So that's what with Java 17 we had the previous ones, but you will not be able to use the latest APIs which is available with Java 18. And there are no flags needed. Only those new APIs and the constructs, if you use, it makes it work. And the second question is the code available on GitHub? So currently the code I have used is not available on the GitHub, but I will try to put it on the GitHub and share it. And the next question is, will there be any guarantee that normal Java thread maps one to OS thread? So see, the normal OS threads, there's no control by the JVM, and it is all is monitored by the OS. What we can control here is the virtual thread will be controlled by the JVM, and there will be for each virtual thread there will be one carrier thread at a time. So that's what we can confirm. The next question is million threads while Eclipse IDE has problems to show thousands. Will there be any changes in Eclipse IDE to support virtual threads? So as I showed, right, I mean, currently there is not much support from the debugging APIs available from the Java perspective. So right now we can just show the threads, but like if you put a bad breakpoint, it will be difficult to debug. And also there we expect the way it will move forward and the way users will use it, we expect some APIs to be supported from the JVM, and then definitely Eclipse IDE will also use those ID, those APIs to be able to show them separately in the form of virtual threads. But currently, there is no distinction, and we cannot get a list of virtual threads from any of the APIs provided by the JVM or the JWP protocols. Okay, so another question is, can you again explain what we need to take into consideration when debugging virtual threads? So debugging, so the breakpoint, the points where we are putting the breakpoint is very crucial while debugging the virtual threads. If we put a breakpoint where we expect all the virtual threads to stop, then it will so as soon as we move from that breakpoint, we just um, try to move out of that, the another some other virtual thread will come and that will be suspended on the same one. So what we want to put is at a breakpoint where not the virtual threads but the main career threads are stopping. And even when we are trying to resume the thread, it should not be for each virtual thread, but what we want is that the whole all the threads resume at the same time rather than each virtual thread, because one virtual thread just proceeds, but the breakpoint is such that the next career thread is going to put the virtual thread and it will break again. I hope it is clear. Or so the next question is, so the main reason for the new virtual thread is for performance and to have less memory consumption. Are there additional benefits? Yes. So these are the main benefits. The context switching is controlled, and we can control, and it's very lightweight, and the performance, that is the main advantage. Also, the advantage here is now the number of threads can be supported will be much more, and the threads will not be blocked. So I think that is one of the main advantage, that the threads will not be blocked for read write or these kind of operations. And the way the Java was lacking behind Go and other languages, where people were moving to other languages to support the new and asked support for the resources which was not being available to deliver by Java. So those things can be easily achieved with these virtual threads. So the another question is, besides debugging, will this affect things like the job framework somehow, or does it basically not matter how jobs are mapped to threads, virtual threads? So if we have the current code and the way we have already written the threads and jobs, and we don't want any performance improvement, we don't need to do anything. But if we are writing a fresh code, or we want, if there are some codes where we have written the jobs and threads which were not performing, so those things should be and can be improved by these virtual threads. So that is the, it will not be mandatory, but if we want to improve the performance of the existing job frameworks, then we can use these new APIs and the new way of concurrent programming. So the next question is, can virtual threads use synchronize as normal? It can use. There is no stopping to use, but people may not want to use synchronize, but there is no as such way that it stops to, no restriction as such, but it is not expected to use, because what we want here is that the threads yield and it gives the opportunity to other career threads and other virtual threads to run while it is waiting. So can virtual threads notify each other as normal threads? So yes, so that is what it is. So the when we are doing a yield and when we are doing a notify, so it can notify all the other threads also. It can notify. The constructs will be different, but it can notify the other virtual threads also. Okay, so Thank you all for listening to this, and do try out these new codes, and these will be evolving, so please do keep it in mind. Thank you.